so that just
everyone?
Yes, it is.
Great. Thanks for the introduction, Antonio, and hello, everyone. Thanks for sticking around for the last session in this open door event. My name is Thijs van den Hout, and I'm a research engineer at SIDN Labs. SIDN is a registry of the Dutch top-level domain .nl, and I work in the research team where we focus on doing technical applied research to make the internet's infrastructure more trustworthy and secure. And in Concordia, we work on developing and piloting a DDoS Clearing House for Europe. And in this presentation, I will introduce and demonstrate the distributed testbed that we've created for the DDoS Clearing House. In this presentation, I'll first give an introduction to the DDoS Clearing House, what it actually is. Then I will explain why we developed a testbed and what this looks like. I'll describe how the testbed is used to test the DDoS Clearing House. And lastly, I'll show the testbed in action through a demonstration that we recorded for a video. So first, what is a DDoS Clearing House? The DDoS Clearing House is a system that enables organizations to share measurements of the DDoS attacks that they handle. This is a summarized information in the form of a so-called DDoS fingerprint. And they can share these measurements, these fingerprints, with other organizations in an anti-DDoS coalition. And I'm sure the previous session already spoke about this, but this is a group of organizations that have committed to fight DDoS attacks collaboratively. For example, by sharing knowledge on DDoS attacks, and through this clearinghouse also share data on DDoS attacks. One example of such a coalition is the Dutch Anti-DDoS Coalition. 18 organizations of different sectors in the Netherlands are members of this coalition. For example, government institutions and banks, telecom, and also organizations that are in the business of handling DDoS attacks. So here they share knowledge and expertise through the clearinghouse and through large DDoS drills that they perform. By joining an anti-DDoS coalition, an organization broadens the view of the DDoS landscape from their own more narrow view to an ecosystem-wide view because of the knowledge of all the coalition members. It's important to note that the clearinghouse is a security mechanism that complements mitigation services, such as scrubbing services that organizations still need to have in place to actually handle large DDoS attacks. The clearinghouse is meant to share information about DDoS within a coalition and where possible help with the mitigation of DDoS attacks. The clearinghouse consists of 3 core components. First is the dissector, which analyzes DDoS traffic captures and from this traffic capture generates a fingerprint that summarizes the attack's characteristics. And this fingerprint includes things like protocol types, packet lengths, source IP addresses, and those kinds of metadata. The coalition members run this dissector in their own network, and they process their own network information just internally. The second component is the DDoS DB, and this is an interactive database that stores and shares these fingerprints that are created by the dissector with the members of the anti-DDoS coalition. The DDoS DB is a shared facility within the coalition among all the coalition partners. Each coalition partner can also have their own instance of DDoS DB, but that one will synchronize with a central instance. And lastly, a converter. This takes as input a fingerprint from the DDoS DB and transforms it into a mitigation rule that can be installed on the firewall at the coalition members. And fingerprints only contain the metadata of the attacks and not the actual attack traffic itself. So coalition partners don't run the risk of sharing privacy or commercially sensitive information. So imagine these are organizations in an anti-DDoS coalition, and one of them receives a DDoS attack. First, they must handle this attack with their own firewall rules or other mitigation services. And after they've dealt with the attack, they can initiate the DDoS clearinghouse cycle. So the clearinghouse is not a tool that is in line with the network information flow of an organization, but can be applied at any given time given a traffic capture of a DDoS attack. So it's not meant to detect a DDoS attack. So this organization gathers data captures of that DDoS attack they received, which is the input to the dissector module, and they have installed this in their own systems. This module creates a fingerprint that describes this attack and stores it in the DDoS DB. Then other coalition members can download this fingerprint and use the converter to create mitigation rules for that specific attack. Then if that attack hits any of the other coalition members, they are better prepared and can more effectively ward off this attack by the mitigation rules they created and the information that is shared through this coalition. This is an example of such a DDoS fingerprint. It contains metadata like the communication protocols, so UDP or TCP, ICMP, the different types of DDoS attacks, the number of packets, the duration, and other information that describes the attack. Now, I spoke of a testbed for this system. So why do we need a testbed, and what does this look like? Our goal in Concordia is to pilot this DDoS clearinghouse in the Dutch anti-DDoS coalition and a coalition in Italy with a few partners, and use this pilot as feedback for a production level system. The obstacle that we're faced with is this pilot being so multidisciplinary. The clearinghouse is not just a technical system, and as was also mentioned in the previous session, the deployment isn't just a technical process. To pilot this system in production in an anti-DDoS coalition, we have to deploy the software in production systems and somewhat change the workflow of these organizations. And that's the first challenge that has been difficult to accomplish because these decisions are often not taken by the people that are open to pilot this project, but more often by higher management positions. Another obstacle is the legal agreements between the coalition members, and most importantly, the data sharing agreements that are necessary. The DDoS fingerprints contain IP addresses of the source of the traffic, and IP addresses are personally identifiable information, so they cannot freely be shared with other parties due to the GDPR. Also, some members of a coalition may not be able to guarantee that the traffic capture required for this cycle doesn't contain any legitimate traffic. Then they will be sharing information of legitimate clients, which may be in violation of their own privacy policies. All these things make it difficult to get a pilot started within a coalition. However, we still wanted such a setup with multiple organizations to test the technical developments of the clearinghouse, which is why we developed such a distributed testbed that I will describe here. First, we set up a few requirements for this testbed. Firstly, it should allow us to test the clearinghouse cycle without the time-consuming process of deployment in production systems and the legal process needed for this system in production, so such as the data sharing agreements. It must also closely resemble the technical operational setting in which the clearinghouse will be deployed after the development phase. So it should operate in an environment distributed over the internet and not in a clean and controlled virtualized network. Lastly, it should allow us to test and demonstrate the different components of the clearinghouse and more importantly, the whole system working together. And we also hope that by showing the clearinghouse in action on this testbed, which is very close to a production environment, that we can convince the partners in the anti-DDoS coalitions that the clearinghouse does actually provide an added value and that it's not as scary as it might sound. The testbed, again, can be divided into three ingredients, let's say. Of course, we need a coalition to provide a platform for the DDoS clearinghouse. In this first iteration of the testbed, we set up a virtual anti-DDoS coalition between two organizations. And we need some way to create DDoS traffic to test the clearinghouse with. So we developed a remote cloud-hosted traffic simulator. And this is probably the most important aspect of this testbed. It consists of 5 servers hosted on a cloud platform that are distributed throughout the world so as to resemble a small botnet that can generate a DDoS attack. Well, we don't want to send a real DDoS attack over the internet because that would introduce a lot more problems regarding liability and the actual mitigation of that attack. We just need a small traffic sample of DDoS attacks to be able to test the cycle of the clearinghouse. So it's not meant to load test one of the partners in this coalition. So we limited the traffic generator to just send small samples of DDoS traffics to the target, like 5 megabytes per second at most, which is not enough to bring down a network. We also created an online dashboard from which we can orchestrate this traffic simulator to send traffic. Each member in this virtual coalition has their own credentials on the system, and they can only send traffic to themselves. With this, we limit the agreements that we need for liability between the members. On this dashboard, we can customize the traffic that will be sent to the requesting member. We can tweak aspects of the traffic, such as the destination ports, protocols, the packet size, traffic speed, etc. And importantly, the traffic that is generated by this simulator does not contain personally identifiable information because the source IP addresses are just those 5 of the 5 virtual machines, and we already know these. So we can freely share these fingerprints that we generate from this traffic with anyone without data sharing agreements. What's also good to mention is that these virtual coalition members have networks dedicated to research, or at least networks that are separate from production networks. So if we do accidentally break something on this platform, it's not that big a deal because we don't meddle in production systems. Lastly, of course, we need the clearinghouse modules deployed throughout the virtual anti-DDoS coalition. So now we have a representative environment with multiple coalition members, everything distributed throughout the internet as it would be in production. And we don't have the drawbacks of deployment in production systems and the data sharing agreements that come with that because of the traffic generator. Then how can we use this to test the clearinghouse? Well, first, the first member of this virtual anti-DDoS coalition requests traffic through the dashboard, this online dashboard that's connected to the traffic simulator. The traffic simulator will then send the traffic that was requested to their servers. The attack traffic is then captured on that server and analyzed by the dissector module, the first module in the clearinghouse, which generates a fingerprint of this traffic, which is then shared with the DDoS DB. And from the DDoS DB, the other members in this coalition can query the fingerprints, and with the fingerprints, create mitigation rules using the converter, which is the last component of the clearinghouse. Then the second step in this process is for the second member to request that same attack that was previously sent to the first member. And then hopefully we can see that this attack is largely blocked by the mitigation rules that were generated by the converter and the information shared between the parties. So we actually did this. We established a virtual anti-DDoS coalition between SIDN, so the registry of .nl, and SURF, which is the collaborative organizations for IT in Dutch education and research. And we recorded this process for a demonstration video that we made. So here I will show these screen recordings and give live commentary instead of just playing the video. Okay, the first step on the testbed is for me to request a sample of DDoS traffic from the traffic generator. And here is the dashboard I talked about, on which I can customize the traffic that will be sent to me. And here I configure the traffic generator to send me a UDP flood attack of 100 packets per second on port 8989 for 15 seconds. And we can see that the traffic is being sent. And here I have a live view of the traffic incoming on the network interface. And this is before any filtering by firewalls. So everything that is sent to this target machine will be displayed on this graph. And in the meantime, I'm capturing this traffic using a command line tool. So in a minute, we can see if we captured some data that was sent by the traffic generator. Okay, this is the tool that's capturing the incoming traffic. And after firewall rules being applied, So yes, this captures the data after the firewall rule being applied. So we can see that we captured some traffic on this interface, and then we can use this capture file as input for the dissector module, which will create a DDoS fingerprint of it. And I'm also telling it to directly upload it to DDoS DB. So that's what this command is doing. So the dissector is now analyzing this traffic capture file, and we get a brief preview of the fingerprint that it generates, and we see that it successfully uploads to the DDoS DB. So now let's check that out. We can visit the online interface of DDoS DB here, and on the overview page, we should see the fingerprint we just uploaded. And it's indeed there. It's uploaded by SIDN Labs. And if we click on the key, we can see the fingerprint there with all the fields that describes this attack that I just sent to myself. We can see that the 5 IP addresses are those of the traffic generator. And if I click this sync button, it can now be seen by anyone in the coalition that visits this DDoS DB interface, so they can download it and use this fingerprint in their for their converter in their networks. So this is the view from the other coalition member, someone at SERV, who will download the fingerprint from the DDoS DB. He's doing this through the command line, so you know he's a professional. And with this fingerprint, he can call the last module of the clearinghouse, the converter. And this will create mitigation rules, in this case, rules for the IP tables firewall, based on the information in this fingerprint. And he can then look at these rules and enable it such that it is applied to their firewall. Okay, now that the mitigation rules are installed, he will also start capturing the incoming traffic using the same command line tool, and then request the same UDP flood attack that I previously requested to be sent to me. And again, here on in this graph, there's all the traffic being sent from the generator, and then while he's capturing, hopefully we can see that the mitigation rules have worked, and we can see a decrease in traffic that he captures using this command line tool. So if he stops capturing this traffic now, there we go, zero packets captured. So that means that the mitigation rule have worked, and the firewall rules have indeed warded off this attack by dropping the traffic that was sent from the generator, namely the same attack that was described by the fingerprint, which was used to generate these rules. So with this testbed, we can effectively test the DDoS clearinghouse technically without the need for data sharing agreements or meddling in production systems. And this is very useful, first of all, to test the technical developments of the clearinghouse. Instead of having to do this for every module separately, we can now use the testbed directly to see how it performs as a whole, which is much more informative. And we also hope that we can show the members of the Dutch Anti-DDoS Coalition how all this works, and hopefully make progress there for a pilot in production, or maybe even start developing the production systems using the outcome from the tests run on this testbed. If you're interested in this, there's always more content online. As I mentioned, we recently created a demo video for the testbed. We've also written a blog to go with it, which I believe will be soon uploaded on Concordia as well, but you can read it for sure on sidnlabs.nl. NoMoreDDoS.org is the website of the Dutch Anti-DDoS Coalition, where you can read more on the anti-DDoS coalitions and how they work. Also, the entire DDoS clearinghouse, so all the components, as well as the testbed, is open source. So you can check out the source code on our GitHub organization page, which is DDoS-clearing-house. Yeah, so thank you all for listening. I hope you found it interesting and informative. And if you have any questions or suggestions, I'd be happy to address them.
Thank you very much. So I suggest to the participants to use the live chat of the question and answers tab.
Yes.
So let's wait just a few minutes if they have any question.
Of course.
I didn't see anything.
Looks like it was very clear.
Yeah, indeed. I mean, I want to highlight you can always contact Thijs via mail or
Yes,
anyway
absolutely.
through the Concordia website if you have any question. And with this session, so thank you very much for this demo.
Yeah, no problem. Thanks for having me.
And so with this demo, we conclude the Concordia Open Door event for 2021. I'm very happy to have you all here. And I hope we're going to meet next year, this time physically. I really hope that. And I again highlight the fact that we have the booths, we have the posters in the exhibition area, and we have also the lounge that are going to be open for the whole day. So thank you very much and enjoy the rest of the afternoon.